This is a video called Stoichiometry. That's pronounced stoichiometry. Stoichiometry from mole to mole. So far, we have learned to count atoms and compounds using the mole. What are our next steps? Well, our next step is to answer the following question. Is it important to be able to count moles of atoms or molecules for a chemical reaction? And the answer is, what do you think? Come on now, you know. The answer is yes. Why do you ask? Well, let's say, for example, we have this chemical reaction. This is a reaction in which nitrogen gas, N2, and hydrogen gas react to form NH3. NH3 is known as ammonia. It's not the ammonia that you guys have in a cabinet somewhere at home that somebody uses for cleaning. The ammonia that you have is this substance dissolved in water, so it's a solution. This is a pure substance. This is a compound, a pure substance. So, let's say, for the sake of argument, I need to make 4.6 moles of ammonia. Maybe I want to make a solution because I want to do some cleaning. I need 4.6 moles of ammonia to make the proper concentration solution. Here's the problem I have. How much hydrogen do I need to make 4.6 moles of ammonia? How much nitrogen do I need to make 4.6 moles of ammonia? I don't want to use too little of either one of these, otherwise I won't get 4.6 moles. I don't want to use too much, otherwise whatever's left over after I get the 4.6 moles, whatever's left over of these two, the nitrogen and the hydrogen, will just go to waste. So what do? I don't know what to do. There's got to be a way that I can figure out how much of each of those I need to get the 4.6 moles. Well, there is a method. It's a method that we use to count atoms and compounds using the mole, and it's called stoichiometry. To count atoms and molecules in a chemical reaction, we'll use this method called stoichiometry. Now, in order to do stoichiometry, my friends, we have to go back and look at a chemical equation and learn about what a chemical equation tells us. So here's a chemical equation. It's telling us that hydrogen gas, H2, and oxygen gas, O2, are reacting to form, because that's what the arrow tells us, water, H2O. It's also telling us that based upon the coefficients, those are the numbers out in front of each formula, that 2 molecules of hydrogen reacts with 1 molecule of oxygen to form 2 molecules of water. Well, we're going to take this idea and we're going to extend it from molecules to moles. It turns out that the mole relationship is the same as the molecule relationship. It is based upon the coefficients. 1 mole of oxygen, based upon the coefficient, requires 2 moles of hydrogen to react with it, and 2 moles of water will be formed. This is known, my friends, as the stoichiometric relationship. The stoichiometric relationship for this reaction says that 1 mole of oxygen reacts with 2 moles of hydrogen, and you'll get 2 moles of water. So, in order for the entire 1 mole of oxygen to react, you must minimally need 2 moles of hydrogen, and you'll end up with 2 moles of water. This is the stoichiometric relationship for this reaction. Of course, the stoichiometric relationship for every reaction is a constant. It never changes. So no matter how much oxygen we actually start with, it must always react. In order for all of it to react, it must react in a 1 to 2 mole relationship with the hydrogen, and we'll get a 1 to 2 mole relationship for the water, so we'll get twice as many moles of water as we start out with oxygen. So for example, let's say we have 10 moles of oxygen. Let's say 10 moles of oxygen reacts. If 10 moles of oxygen reacts, if this relationship is true, if it's a 1 to 2 relationship, how many moles of hydrogen should react with it? And how many moles of water should form? Well, If 10 moles of oxygen reacts, and this is truly a 1 to 2 relationship, then we require 20 moles of hydrogen to react with it. So 10 moles of oxygen requires 20 moles of hydrogen to react with it, and will form 20 moles of water. This is a 1 to 2 relationship, just like written above, and this is a 1 to 2 relationship. So remember, it doesn't matter how much oxygen we start with. If we have a certain number of moles of oxygen, in order for all of it to react, twice as many moles of hydrogen must react, and we will form twice as many moles of water. Let's say instead of 10 moles of oxygen, we have 100 moles. Since it's going to follow the stoichiometric relationship, if all 100 moles of oxygen react, it must react with twice as many moles of hydrogen. That's 200 moles, For every 100 moles of oxygen that reacts, 200 moles of hydrogen must react with it, and we will form 200 moles of water in a 1 to 2 relationship between reactants and a 1 to 2 relationship between O2 and the product, H2O. So, let's take this a step further, and let's look at a problem. It's going to look very familiar. It's going to look very similar to the problem that we mentioned earlier in the video. How many moles of H2 will react if 4.6 moles of NH3 is formed according to the following equation? Remember, I wanted earlier to know how much hydrogen I'm going to need, or how much nitrogen I would need to make the 4.6 moles of NH3 that I want to form. Well, there's the chemical reaction, which is going to be written twice. So there's the equation. The top one right here is part of the problem. I'm going to take that equation and write it down here. Now there's an arrow that you saw was here at the beginning, and it has a purpose, and you'll see momentarily what its purpose is. So the first step is to rewrite the chemical equation, and there it is, the nice balanced chemical equation. The second step is to write down the stoichiometric relationship. So based upon the coefficients, 1 mole of N2 requires 3 moles of H2 to react with it to get all of the N2 to react, and when 1 mole of N2 reacts with the 3 moles of H2, we'll get 2 moles of NH3. So we want to be able to count how many moles of H2 will react to make 4.6 moles. Well, it's got to do so in a 3 to 2 relationship. So what I like to do next is take the 4.6, which is the number of moles of NH3 that we'd like to make, and write it above the NH3. And since I'm trying to find out how many moles of H2 will react, I'll put a question mark over the H2. I'm going to follow the arrow, and I'm going to take the 4.6 moles of NH3, which is given, and I'm going to multiply it times the 3 moles on the bottom. Remember, the 3 moles is determined from the stoichiometric relationship. So I'm going to take the 4.6, I'm going to multiply it times the 3, and I'm going to divide it by 2. I'm just doing this in terms of relationships, because if this is a 2 to 3 relationship, then this has to be a 2 to 3 relationship. If 2 to 3 is the relationship, the stoichiometric relationship, then 4.6 to whatever this answer is, that must also be a 2 to 3 relationship. So we multiply the 4.6 times 3, and then we're going to divide it by the 2, just like we have right here. So we take 4.6, multiply it times 3, divide it by 2, we come up with 6.9 moles of NH3. 4.6 and 6.9 is in a 2 to 3 relationship. It's not that easy to see, but it is a 2 to 3 relationship, because this relationship can't change. Remember, no matter how many moles of NH3 I form, the relationship between the NH3 and the H2 is a 2 mole to 3 mole relationship. And so for every 4.6 moles of NH3 that reacts, 6.9 moles of H2 must form. And I apologize, this right here is supposed to say H2. So in your notes, please cross out NH3 and write H2 instead. My fault. I make mistakes. I'm not perfect. I know it's hard to believe, but I'm still good looking. Let's look at another problem, shall we? How many moles of NH3 will be produced if 4 moles of H2 reacts according to the following equation? Again, that's how many moles of NH3 will be produced if 4 moles of H2 react according to this equation. Well, we said in the first step we rewrite the equation, and there it is, the balanced chemical equation. Then we write down the stoichiometric relationship, and there it is, based upon the coefficients. 1 mole of N2 reacts with 3 moles of H2 to form 2 moles of NH3. Next, we go to the problem, and we see we're interested in forming 4 mole, or reacting 4 moles of H2. Not forming, but reacting 4 moles of H2. So I'm going to put the 4 above the H2, and the question is how many moles of NH3 form. So I'm going to put a question mark above NH3. So let's reread it again. How many moles of NH3 will be produced? So I'm going to put a question mark above NH3, and it says if 4 moles of hydrogen react. So I'm going to put 4 above it. So again, this is a 3-to-2 relationship, so whatever this answer is, it has to be in a 3-to-2 relationship with the 4.0. So in order to figure it out, I'm going to take the 4.0, the amount given, and multiply it times the stoichiometric number of moles of NH3, and then divide it by the 3 moles of the H2. So it's 4.0 times 2, right? 4.0 times 2, divided by the stoichiometric number of moles of H2, which was 3. And when we divide it out, we get 2.67 moles of NH3. And the relationship says it's a 3-to-2 relationship. So this is 4 moles to question mark, and question mark is 2.67 moles. So 4 moles to 2.67 moles is also a 3-to-2 relationship. Let's try another problem. How many moles of N2 will react if 3 moles of H2 reacts according to the following equation? So there's the equation. We want to know how many moles of N2 will react if 3 moles of H2 reacts according to this equation. So again, we rewrite the balanced chemical equation. That's our step number 1. Then we write the stoichiometric relationship, and again, that comes from our coefficients. Remember, the question says how many moles of N2. So I'm going to put a question mark over N2, and it says will react if 3 moles of H2 reacts. So I'm going to put the 3 over the H2. So the question mark goes over the N2, the 3 goes over the H2, and now we do the same thing. Take the 3 moles that are given and multiply it times the N2, and then we divide it by the 3. So we're going to take 3 moles given, multiply it times 1 mole of N2, divided by the 3 moles, and see that we get 1 mole of N2. This makes complete and total sense, my friends, because it says that the stoichiometric relationship is a 1-to-3 relationship. Therefore, if I give you 3 moles of H2, it has to react with 1 mole of N2, because that relationship has to be 1-to-3. Okay, that's the end of our video, and come to class tomorrow with lots of questions, lots of notes, and ready to solve problems. We'll see you tomorrow. Bye. Oh, and by the way, I just wanted to let you know, as we go backwards to one of the original slides, one of the important things, what are our next steps? Well, our next step is to make sure that we use correct correct punctuation, because I forgot the question mark at the end of this question. I'm sorry. I apologize. I'll see you tomorrow. Goodbye.